Okay, good morning, class. I don't see anybody here yet, but hopefully some students will join us. We're going to go over a copy of the final exam preparation quiz, and some of the questions here need some calculation, so I've got a detailed solution for certain questions, and when that comes up, I'll pop over to that screen here, and those will also be posted in my courses for you. And also the formulas that you were given, I'm not going to pull those up here, but those will be available to you in the final exam also. Okay, so let's go ahead and get started. A number that can be substituted for the variable in an equation and results in a true statement is called, and that's called a solution. And remember, the first four questions here on the actual final exam are going to be short answers, so you're not going to have a multiple choice. You're going to have to type in an answer. When solving equations with parentheses, we might use what operation to remove the parentheses? Remember, that operation is called distribution. What kind of a function or what type of a function is written in this form? Remember, that was the exponential form. The collection of all possible outcomes is called the, and this is talking about probability, the sample space. All right, so from now on until the last question, these are all going to be multiple choice. So this is a solving problem, and I've got a detailed solution for this one, so let's just pop over here. And the detailed solution is going to be, let me make this bigger. Notice my steps here. I need to get x by itself, so I'm going to add 6.8 to both sides, and when I do, I get an answer of x equal to 23.3, which I go and I check is one of the answers, 23.3. Another solve one, I'm not going to pop over to the detailed solution. In this case, you want to isolate the variable c, so you're going to divide both sides by negative 2.6, and when you do that, you end up with an answer of positive 6, which is the second choice. Notice the answer is positive because you're dividing a negative number by a negative number. Identify the operation that you need to do to perform to this equation to isolate the variable. So remember, we talked about reversing the operation. So the variable here is n. It's being divided by 7. So if I want to reverse the operation to isolate n, I'm going to multiply both sides by 7. Number 8, translate into an equation and then solve. And I've got a detailed solution for this one. Okay, so let's let x be the payment, and she's got a balance of negative $4.55 on her credit card. What payment should she make to get the balance to negative $169? So she started at negative $455. She's going to make a payment of x dollars, and she's going to end up with a balance of negative $169. So this would be the equation, and we're going to add $4.55 to both sides, and we come up with an answer of $286. So Betsy needs to pay $286 in order to bring her balance up to negative $169, and the answer here is C. Number 9, is x equal 3 a solution to this equation? Again, let me pop over to the detailed, and what do we do to check that? We take that number 3 and we substitute it in, see if we get a true statement. So I took 3 and replaced x with 3 all the way through. On the left side, I simplify. I've got 27 plus 8 is 35. On the right side, I've got 4 times 3 is 12 plus 22 is 34. They're not equal, not a true statement, so therefore x equals 3 is not a solution. So the answer for this one is no. Another solve problem. And I notice on this one I've got parentheses on both sides. So the first thing I'm going to do is distribute on both sides. So on the left side I get 6x minus 9 equals, on the right side, 5x plus 10. I'm going to go ahead and subtract 5x from both sides, and I get x equal minus 9 equals 10. Add 9 to both sides, and my answer is x equals 19. And remember, I can go back and check that answer to make sure that it is the correct answer. Another solve problem. Let's pop over here. First thing I did on this one was I want to isolate the z term, so I went ahead and subtracted 2z from both sides. I get z minus 5 equals negative 8. Add 5, so z equals 3. Again, I can check that answer in the original equation to make sure I get a correct answer. I'm sorry, I forget the answer. I went too fast. X equals negative 3. Okay, so the answer is D. And now I want to solve the formula for the specified variable. So let's pop over here. So that's basically isolating that variable, and we want to solve it for the variable capital R. So the first thing I need to do is get this term by itself. So the first step is going to be to subtract p from both sides. So now I'm at this step here, and I want to solve for R. So again, reverse the operation. R is being multiplied by p and t, so I'm going to divide both sides by pt. And my final answer is given right here. A minus p over pt. So the correct answer is B. Okay, another solve equation. I'm going to pop over here for number 13. The first thing I'm going to do is multiply both sides by 2 to clear the denominator. So I multiply the left side by 2 and the right side by 2. So it clears out the 2's here, so I'm left with 4 times 3x plus 4, and on the right side I'm left with 2 times 4x plus 24. Distribute on both sides, so 12x plus 16 equals 8x plus 48. Subtract 8x from both sides. So on the left side I've got 4x plus 16, and on the right side I've got 48. And then I'm going to subtract 16 from both sides. So 4x equals 32, and finally divide both sides by 4, so x equals 8 is my solution, and that is answer B. Okay, another solve problem. Let's go back over to the detailed solution. This kind of problem was a problem that students seem to have trouble with, and we went over these in we did go over them in the course, section 3.16 in our book. And so we've got the original equation as the square root of the quantity 5x equals 2. And think about reversing the operation again. We're taking a square root, so the reverse operation is squaring. So I'm going to square both sides. When I square a square root, I simply get out the quantity that was under the square root sign. So now I've got 5x equals 4. And then divide both sides by 5. So my answer is x equals 4/5. And that's choice A. Translate to an equation and solve. All right, so remember how to translate. 40 equals what percent? The percent I'm looking for is x, so x times 32. Divide both sides by 32. I'm trying to isolate x. And so I end up with 40 over 32, and I want to simplify that. Numerator and denominator are both divisible by 8. So that gives me 5 over 4, or 1.25, and I want the answer as a percent, so it's 125%. Notice the number I'm interested in finding the percent for is larger than the base number, so I would expect to get a percent greater than 100. If it was just 100%, it would be the same number. So we're going for actually increasing from 32 up to 40, so we know we have got more than 100%. Okay, another application problem. Let's pop over here. Last year, Maria earned $326 per week. This year, her salary increased to $362 a week. What is the percent of the increase? Round to it, nearest tenth of a percent. So remember the formula for percent change. It's final minus initial divided by the initial. So she ended up at 362. She started at 326. I divide by 326. Do the subtraction in the numerator. I get 36, and then I take 36, divide by 326, and I get 0.1104. And as a percent, multiply by 100 or move the decimal 2 places to the right, the answer is 11%. So Maria got an 11% increase. All right, another percent change problem. After receiving a discount of 15.5% on its bulk order of typewriter ribbons, John's office supply paid $6,591. What was the price of the order before the discount? All right, so if they received a 15.5% discount, if they started at 100% and they received that discount, they actually paid 84.5% of the original price. So I can write this as a sentence, let x be the original price, 84.5% of the original price is $65.91. Convert the percent to the decimal. So divide both sides by 8.845, and we come up with an answer of $7,800. And notice this price is more than the discounted price because obviously he received a discount. So we would expect that the original price was higher. So the final answer is $7,800. Okay, Pythagorean Theorem question. All right, we're trying to find the height here to the top of the pole, and we know the length of this rope here, and we know the distance that it ends up away from the pole, so we can use the Pythagorean Theorem. This is a leg, and this is a leg, and this is the hypotenuse. So here's our equation. A squared, I'm going to let that be A, plus 22 squared equals 30 squared. Square 22 and 30, and then subtract 484 from both sides. So I've got A squared equals 416, and I need to take the square root. I know that 20 squared is 400, so I know the answer is a little bit more than 20, and in fact it comes out to be 20.4. So the answer there is 20.4, and the units are yards. Okay, another solve with a proportion, and what are we going to do for this one? We're going to cross multiply. So 3x equals 4 times 9, or 36, divides both sides by 3, and so we find x equals 12. And that's answer B. Solve the problem. Let's jump over here. A machine in a factory produces 420 units each hour. How many units does the machine produce per minute? Okay, so this is a unit conversion problem. So we want to know the units per minute, and we know there's 60 minutes in an hour. And so 420 per hour is the same thing as 420 per 60 minutes. Go ahead and set up the proportion and solve, cross multiply. So therefore x must be 7. So it must be making 7 units per minute in order to produce 420 units per hour. So the answer is 7. Okay, this is a problem with a little table in the beginning where you're looking at the pattern. So let's take a look at the pattern and see what we see. X has gone up by 2. Y we want to solve for, we want to fill in here, and Y looks like it's gone up by 6 each time. So 2 plus 6 here would be 8, and 8 plus 6 here would be 14. So there's my completed table. And let's find, we want to graph this now. So the Y-intercept is 0, 2. We can find the slope from the table actually. Okay, the change in Y is 6 and the change in X is 2. So the slope is 3. So you can graph it now with the Y-intercept and the slope, or you could just use 2 points from the table. And if you go ahead, I don't think I brought the graph over. No. So let's take a look at the pictures for a minute. 0, 2 is the Y-intercept. It's a little hard to see on here. This one looks like it goes through 0, 2, and it's a positive slope. And the actual answer is A. It's really hard to see on here, but the answer is A. It was a positive slope, so right away I can eliminate C and D because they have negative slopes. Notice the difference here. On B, it's going through the point 2, 0 rather than 0, 2. So you want to watch out for the intercept being on the correct axis. Okay, another graphing problem here. Graph the line that goes through the given point with the given slope. Okay, it's a negative slope, so we know that all the graphs are a possibility. We want to see which one is going through. I think I have this one over here. Okay, so I could find another point. I've got a point on the graph, and I need another point, so I could use the slope being rise over run, and the slope is negative 1/4. So the run is 4 and the rise is -1. So I could find another point from 8, 0, or on the graph alone I could use this point and then use the slope. So let's take a look. So it's 8, 0. So first let's check the graphs and see if they're all crossing the axis at 8, 0. This one is not, so I can eliminate B. This is crossing at, I'm not sure. This one's not crossing at 8, 0, nor is this one. So it's got to be A. Let's take a look and make sure it makes sense from the slopes. Remember, the slope was -1/4. So if I'm at this point, and let's say I want to go ahead or go back a point actually, so I can go up 1, back 4, up 1, back 4. So the correct answer here is graph A. Find the slope and the y-intercept of the line. So this line is in y equals mx plus b form, so I know the slope is 5, and I know the y-intercept is 0, -2, which is choice B. Remember, the y-intercept has an x and a y coordinate. Assume an exponential function has a starting value of 8 and a decay rate of 0.32%. Write an equation to model the situation. Okay, so here's the starting value, 8, and that's in all my answers here. Now, it's a decay, so I know that the multiplier here has got to be less than 1, and I'm actually going to change this to the decimal, which would be 0.0032, and subtract it from 1, and that's going to give me answer B. And here's another exponential one. Starting value of 12, growth rate of 0.32. So we started at 12. The growth rate is so again, change it to the decimal. It's going to be answer B, 1.0032. Those are a little tricky. The value of your car is decreasing 8% per year. If your car is worth $9,347 today, what will it be worth in 2 years? Okay, I've got a detailed solution for this one. All right, so we can write the formula, the exponential formula, because it's losing 8% per year. Then we've got 92% left, so the multiplier becomes 0.92. And in this problem, we started at 93.47, and we want to know what it's going to be worth in 2 years. I substitute that into the formula, and then I'm going to do the exponential part first. I get 0.8464 multiplied by the starting value, and so the car is currently worth $79.11.30, which is answer B, and it is exponential because it also asks you to identify it was linear or exponential. This is exponential. Okay, graph this equation. Y equals negative 5x. All right, so we need some points. Well, actually, we can see the y-intercept here is going to be 0, 0. So I can look and see all of my graphs go through that. It's negative slope, so I can eliminate any graphs with a positive slope. This has a positive slope, and this one. So it's got to be between B and D. So let's think about what the slope is. The slope is negative 5. So if I start at this point, x goes up by 1, y goes down by 5. X goes up by 1, y goes down by 5. So the correct answer for this one is C. A fair coin is tossed 5 times and head or tails is noted. How many different outcomes are in the sample space? All right, so remember how we did this one? It's going to be a 2 times 2. It's going to actually be 2 raised to the 5th power. Remember, this is the fundamental counting principle, and that actually is 32. All right, a local store sells carpet in 3 sizes. Each carpet comes in 2 qualities. One size of carpet comes in 6 colors, and the other sizes come in 2 colors. How many different choices of carpet are there? Okay, so we've got 3 sizes, 2 qualities, and then one size comes in 6 colors, and the other size comes in 2 colors. All right, so one of the sizes, I don't think I have a detailed solution on this one. Let me go check. No, I don't. Okay. Whoops. So let's go ahead and write out what's going on. So let me type, actually, it'd be easier. All right, so one size, whoops, 6 colors, and then 2 sizes have 2 colors. And then it also tells me that there's 3 sizes and there's 2 qualities. All right, so each of these colors is going to have 2 qualities. So what's that going to give me? 6 times 2 is, this one's going to give me 12. And then this one's got 2 sizes, so 2 times 2 times 2 is going to give me 8. So altogether I've got 20 different types of carpet. Okay, here's a probability question, and I've got a detailed solution for this one. All right, so we've got the number of siblings for students at a middle school. They asked the students how many siblings they had, and the students answered anywhere between 0 and 7. And we want to find the probability if we select a student randomly, that student has 2 siblings. And 140 students said that. I need the total number of students who responded. So I add all these numbers up and I get 682. And then I take 140 and divide by 682 and I get 0.205. And that is answer C. Let me see if I have a detailed solution on this one. No, I don't. Okay. On a multiple choice test, each question has 7 possible answers. If you make a random guess on the first question, what's the probability you're correct? Okay, so it's just going to be 1 out of 7. All right, this one has a detailed solution. Let's jump over. So we're looking at different degrees, and this is the distribution of Bachelor of Arts degrees conferred at a local college by major. What's the probability that we got a degree in English or chemistry? Okay, so we have the total already. We don't have to do that. And then English and chemistry were 2073 plus 318. So we're going to go ahead and add those together. So we get 3,291 divided by the total number of degrees, and so the probability of selecting a student with a degree in English or chemistry is 0.257, which is answer C. Okay, number 33, we have a detailed solution for this one. We're drawing a card from a card deck now. And again, remember, you'll have these available in the actual final exam, the formula, the picture of the cards. We're drawing one card. What's the probability we get a face card or an 8? Okay, so remember, picture of face cards are here, or an 8. So there's 4 8s, and how many total picture cards or face cards? There's 12. Okay, so it's going to be 12 out of 52 plus 4 out of 50. Oh, I should say 52. Sorry, let me just change that. The denominator didn't change. So there's 4 8s. And there are 12 picture cards, so 16 out of 52, which simplifies to 4 out of 13, which is answer B. In a town, one town, 42% of all the voters are Democrats. If we pick 2 randomly, find the probability that they're both Democratic. So let's go over here. So the probability when I pick the first one that they're a Democrat is 0.42. They're independent, so we can use the multiplication rule. So the probability the second one is Democrat is also 0.42. We multiply those and we get 0.1764, which rounds off to 0.176, which is answer B. A die is rolled. Here's the outcomes, 1 through 6. Find the probability that we get a number less than 1. Since all the numbers are less than 9, rather, we know that probability has to be 1. Okay, number 36. I've got a detailed solution on this one. So in a survey of American women who were asked to name their favorite color, 18% said blue, 15% red, 15% green, 12% yellow, 13% black, and the rest said another color. If you pick somebody at random, what's the probability she named another color? All right, so we're going to find the probability of the other color, we're going to use the complement rule, which is 1 minus the probability of all the other colors. And it turns out it's 0.27. So the answer for this one is 0.27. Okay, and we're getting to the end here. So this is number 37. This is our review of the statistical. Cycle 5. The average salary of all assembly line workers at a certain car manufacturer is $45,000. This figure can be described as what? Because we're talking about all the employees, this is actually a parameter and not a statistic. Classify the variable as categorical or quantitative. Person's weight in kilos. Okay, it's quantitative. It's got units associated with it. It's a number. Determine whether the report describes a census, a survey, observational study, or an experiment. Let's take a look. An educational researcher was interested in examining the effects of the teaching method and the effect of the teacher on student scores on a reading test. Suppose there are 4 teachers and 3 different teaching methods. Students were randomly assigned to a teaching method and a teacher, and then those who studied with Sonia using method B had the highest scores. So this is actually an experiment. We're randomly assigning the students to the treatments. Identify the sampling method. In order to determine the expected number of broken eggs per carton, an egg packaging worker selects a group of 50 cartons that come off and counts the broken eggs within those cartons. Okay, so they're taking a random selection of cartons and counting all the items in the carton. So that's called cluster sampling. Here's the heights, and we want to find the range. So let me go over here to my Oh, and I'll have a detailed solution on this one because it's pretty easy. So to find a range, what do? You take the maximum minus the minimum, and let's see, the maximum here is, looks like 6.2, and the minimum is, looks like 5.4, and I think there's a typo in this one. So the range is equal to 6.2 minus 5.4, which is 0.8. And that actually, and I know I fixed this in the actual practice midterm, is actually 0.8. It's answer B. Okay, find the standard deviation for the given data. So I'm going to pop over here because I need to make my little table up. So the first thing you're going to need to do is find the mean of the data. So you add all the data values up and divide by the number of data values, which is 9. And I get 11.44. And then I'm going to take every data value, subtract the mean, get my answer here, and then I'm going to square that. Remember, we call these the deviations. Square them and add them all up. And I came up here with 318.2224. Divide that by 9 and then take the square root, and we come out with an answer around 5.9 for the standard deviation, which is answer A. Okay, you don't actually have questions on the practice midterm to answer, but this is the way the last question on the midterm, I'm sorry, on the final will be. It'll be a free response question similar to the Module 5 discussion and the last problem in the concepts and applications. You'll be given a summary of a research study. You'll read the report and answer questions such as, what is the population of interest? Is this a survey, observational study, census, or an experiment? Did they use a sample? What kind of a sample? If it's an experiment, what are the treatments? What kind of conclusion was drawn? How does the conclusion relate to the population of interest? And so here are some sample summaries. Read these and think about how to answer the questions above. And also you want to look at the homework problems from the second part of cycle or module 5. That will also help you. And I've given you 4 scenarios here so you can get an idea of what you might be given on the actual final, and you'll be asked to select several of these questions to answer. Okay, so that's the end of our review. I'm sorry there weren't any students here today, but hopefully this will help you get prepared, and I will publish the detailed solutions. They'll be in the final exam module in my courses, so you also have the worksheet here that I used today during the chat. So good luck on your final, and good luck in your future math courses. Maybe I'll see you in another course in the future.